Before beginning the experiment, we gathered the following materials: a 25 milliliter volumetric flask, a graduated pipette, pipette bulb, and some of the 20% sugar stock solution. When preparing the stock solution, we used as little as needed for the completion of the experiment. First, we used an analytical balance to weigh the volumetric flask, which looks like this, and other materials needed for the lab that day. Next, to demonstrate a meniscus, Michaela drew up the water using a pipette bulb. Water forms a concave meniscus because the water molecules are more attracted to the glass pipette than each other. To read the meniscus value properly, it must be at eye level and you read the value under the curve. So for example, in this picture, the meniscus reads 20.1 milliliters. You estimate to the 10th place for more accuracy. Now that we had all of our supplies, now it was time to dilute the stock solution. A stock solution is a concentrated solution prepared to be more cost-effective and make less waste. It's intended to be diluted or made less concentrated for use. Due to the experiment requiring varying concentrations of the stock solution, we needed to dilute some of it. Diluting a substance requires adding solvent, which in this case was water, to the concentrated stock solution until the desired concentration is achieved. The formula we use for this is C1 times V1 equals C2 times V2. The C is for concentration and the V is for volume. This clip features Carmen and Mahogany as they dilute the sugar stock solution with water.
We began by pouring the solution into a graduated cylinder and recorded its volume. We then poured some into a new container, then recorded the volume of what's left in the original container. To find the volume delivered, we subtracted the final volume from the initial volume. After finding the volumes of all the solutions, we then found the concentration by using the concentration that was given, and both of the volumes that we found, we multiplied concentration 1 by volume 1, and then we divided it by volume 2 to get concentration 2. For our first dilution set, we used the original concentration of 20%. We multiplied it by our volume 1, which was 5 milliliters, and divided it by our volume 2, which was 10 milliliters, which gave us a concentration of 10%. To get our dilution factors 2 and 3, we followed the same steps and got concentration 6.67% and concentrations 5%.
Lastly, we gathered all our materials and cleaned our lab area.